Hello, I'm Richard from Telesoft Technologies, and I'm going to talk to you today about our 400 gig low latency processing capabilities. Quick history of Telesoft: all staff are security cleared. We do a lot of work with government and telecoms customers, and we have a heritage of high rate products deployed in very complex networks. We are privately owned and self-funded. We are owned and run by engineers, so we have the freedom to create these bespoke solutions to benefit our customers. We're experts in low latency cyber and the unsampled network processing, as the natural thing there is to see every single packet. Quick background on our capabilities: everything we do is in-house, so from the design and the manufacturing of the hardware, all of the programming, right through to the end support is all in the UK. We have no reliance on any third-party systems. FPGA capabilities, we focus extensively in the high-rate data processing area. So multi-100 gig connections is pretty typical for what we handle. Our latest hardware is quantum ready. We have quite a lot of cryptographic expertise in quantum resistant algorithms, in encryption and decryption at 100 gig, and a long history of FPGA leadership in highly complex environments. I'm going to talk to you quickly about our latest hardware, the 7000 card. This again was designed in-house specifically for the high throughput, low latency processing space. The heart of this is an Intel Agilex I-Series FPGA. It has 400 gigabit Ethernet connections and PCIe Gen 5x16, and it's really focusing on processing real-time, high-rate network traffic. The architecture I'm going to demonstrate today is our OPRA Decode, where we start with our 400 gigabit ingress. We go through a packet classification to do the IP decode and the VLAN removal if necessary. We then go into the OPRA decoder itself, where we're extracting the OPRA messages. We then move on to the OPRA filter, which is runtime configurable to filter out any messages that will not influence your trading decisions. So I'm now going to show a live demonstration of this running. The demonstration consists of two servers. The first server is our artificial feed, our 400 gig OPRA feed. This was created using a multicast OPRA feed that was sampled last August. We've taken a few of those packets, we've squashed them together to speed them up, and then we've run them on a loop to synthetically generate a saturated 400 gig OPRA feed. We're going between the cards using QSFP-DD transceivers on OM4 fiber into the second card, which also has a 7000 card in, which is where we are running the OPRA decode previously described. So before I start the demonstration itself, I'll talk you through the dashboard. The three dials at the top, these are real-time rates. The first dial showing the ingress network traffic rate. The second dial showing the number of IP packets received per second. And the third dial showing the number of OPRA messages decoded and passed per second. In the top right, we have aggregated counts or running totals, showing the total amount of data ingressed, the total number of IP packets received, and the total number of OPRA messages decoded. The two graphs at the bottom, again, are running totals, the total number of OPRA messages filtered by participants and by message category. So we have a demonstration app running, which is pulling these statistics, and it's also sampling the OPRA messages once per second, just to make them human readable, and they will show up in this panel at the bottom, just so you can see some of the raw messages being received. This whole GUI is in Grafana, so it can easily be modified or adjusted if you have specific visualizations that would be better fitted for your specific application. That's certainly possible. Or if you like no GUI at all, then you can run the whole system using the REST API or the command line interface. So I'll now start the 400 gig OPRA feed. And we should pretty quickly see the data start appearing on the graphs. Again, this 400 gig feed is the one I've previously described. So we've taken some multicast packets off the OPRA feed, squeezed them together, and then we've looped them at 400 gigs. So this is a fully saturated 400 gig OPRA feed. So we can see the values here. We are receiving 335 gigabits per second of data, 335 million IP packets per second, and decoding 629 million OPRA messages every second. If we start looking at some of the graphs here, I can see that the NASDAQ BX options participant is sending the most messages. So let's go and take a look at some of the filtering we can do. So the current filtering options we have are filtering our OPRA messages by participants or by message category. Obviously, we can do more complex filtering setups. If there is a particular setup that would benefit your application, please do let us know. There's a lot more we can do other than just participant and category. But for the purposes of this demonstration, I'm just going to filter the NASDAQ BX options participant just because they're sending the most traffic and it's the best visualization. So by unchecking NASDAQ BX options, I've filtered out their traffic. And we can now return to the overview, where we should shortly see our NASDAQ BX options line start to flatten out because all the packets from NASDAQ BX options are being filtered out. The benefits of doing this filtering in the FPGA are that first of all, we're reducing the amount of OPRA messages sent up to the host. So this is reducing the software processing for messages that ultimately aren't going to influence your trading decisions. And that overall has the effect of reducing your total latency. The other benefit of doing this specifically in an FPGA card designed for this task, rather than a generic NIC card, is that this FPGA product is removing all of the IP headers, the Ethernet headers, optional VLAN headers, any VDP headers, and then we're opening up that OPRA message, going through the block header, decoding every message, and then we're processing all of them in parallel. If you use a generic NIC card for this, that stepping through, deserializing the OPRA message has to be done in processor. And if you've got a lot of OPRA messages in a frame and you only want the last few messages, you have a long deserialization delay to reach that last message. With the FPGA solution, all the front messages are filtered out, you just get the final messages. The messages are all sent up to the host as well in a beautiful 64-byte fixed format, so they all look the same, meaning your software processing is even faster. So just to summarize, we have successfully filtered out NASDAQ BX options, other filters are available, and just in the last few minutes, we've received over 6.5 terabytes of data, nearly 55 billion IP messages, and over 100 billion OPRA messages. I hope you've enjoyed this. If you've got any questions, please do get in touch. Telesoft-sales@telesoft-technologies.com. Thank you.